All right, so here I'm going to try to find the minimum area where I have a rectangular page that's going to have 24 square inches of print, so this in the middle. And the margins at the top and the bottom are going to be 1.5 inches, and the margins on the left and right are going to be 1 inch. And so we want to figure out what dimensions the page need to be so that the least amount of paper is used. So here we have a picture of showing this. So let's make it clear what we're dealing with. So let me like extend this. If you're not given a picture for a problem, make sure you make one, make it like a sketch, something to basically be a visual of what you're doing. It's going to make your problem solving a lot easier. So here we're given that y is going to be the width of this print area, and the x is basically the the length or the height of this print area. And the margin here is 1.5 up, 1.5, 1.5, and so forth. So this is our print area, and this is going to be 24 square inches. So let's see what we got here. So we have that we want to figure out the dimensions of the page that the least amount of paper is used. So we're going to have area represent the page, the amount of space or basically the amount of area that the page uses. And area is they're basically going to be the length times the width. In this problem, it's given that the width is y plus 1 plus 1. So the width across will make it y plus 2 because you have 1 and 1. The whole thing is, let me label here the width of that area across. Oops, let me make that actually the other way. Well, let me put width. Let me just put width times length so I don't have to. Width times length. Width cross y plus 2. Length up bottom. So this plus that. So x plus 1.5 plus 1.5 or x plus 3. And we're giving it right here, but I just wrote it here to kind of clarify what's going on. So again, area is the width times the length of the paper, and we have y and x shown here to represent those quantities. Now, we're also told that the area of the print is going to be 24 square inches. So 24 would then be y times x. Okay, so here's the thing. Our primary equation is area. And if we use technology, if you're an engineer and you could, you're solving this problem, you can use, some program to graph this area equation, has multivariable equation. And basically you look at the graph and see where the lowest value is. So you're looking for the minimum of it. Now, we're not going to use technology here. We're going to learn to do this by hand. So, what essentially you want to do is study the equation of the area by figuring out where the minimum is, and that's where we're going to use the derivative in critical values. Now, the problem right now is that we have two variables for the area. We're only dealing with one variable calculus up to now, so we need to write the area in terms of just y or just x. So let's just make it in terms of x, just because we're used to having a function of x. So we're going to write the area in terms of x. And for that, we're going to use our other equation where we have 24 equals y times x. Because if we basically just rewrite this in terms of y, let's divide both sides by x. Then we have that 24 over x equals y. And then we could just put that here. And what that does is that, let me just go to this one here. This allows us to write our area as 24 over x plus 2 times x plus 3. Now we have an equation for area in terms of just x. So now we're good. Now we just basically have to find the critical value study what's going on there, study that's a minimum, maximum, and then basically figure out figure out that x value and y value at the critical value, and then we can know our dimensions of the page. So let's first clean this up or make this a little neater to work with. So distributing 24 of x times x, probably just be 24. 24 of x plus 3, so plus 72 over x plus 2x plus 6. And I could just rewrite this as 2x plus 72x to the negative 1 plus 30. Here's my equation for area. So let me now differentiate this with respect to x. I'll get 2 minus 72x to the negative 2. And now let's find the critical values. So find where this is equal to 0. Where it's equal to 0 or it's undefined. So it's 0 would then be 2 minus 72x to the negative 2. Solving for x, and we add 72x to both sides. Or 72x to the negative 2 to both sides. Using algebra, multiplying both by x squared divided by 2. I'll get 36 equals x squared. And so then x could be negative 6, and then my other values for x, the critical values could be negative 6 and 6. My other one would be x equals 0. It's undefined for x equals 0 as well. So I have 3 critical values technically. 0, negative 6, and 6. Now here's the thing. Since we're dealing with a real context, real life context where we have a paper with dimensions, it wouldn't make sense for x to be 0, because if x is 0, there'd be no print. This would not work. So we don't have to worry about checking that. If x is negative 6, this would also not work. Because, again, we can't have negative dimensions. So we really just have to check x equals 6. Now x equals 6. This would be basically our possible extrema. But here's the thing. We want to make sure that this is going to be give us a minimum. So we want to study what's going on with the area when the x value is below 6 and when it's above 6, just to be sure. So what you basically can do is kind of like we're doing in we did in section 3 and section 4 of this chapter. Basically just check the intervals from 0 to 6, and then from 6 and up. And see what's going on with the first derivative there. Now, as long as the first derivative is decreasing before and increasing after, then we're good. So let's just check f prime of 1. And let's say f prime of 10 just to make our numbers easier to work with. So f prime of 1, we just plug 1 into this equation. And that would give us 2 minus 72 over 1. So 2 minus 72. And that would be negative 70. So this is a negative value. Now f prime of 10, plug in 10 into here. So 2 minus 72 over 100. And remember, the 72 over 100 will be like 0.72. So this will be like, this is going to be a positive number. So positive. This is going to be less than 1, so 2 minus 1 will be less than 1. So then we know that the function, or the area in this case, the area is going to be decreasing before 6 and increasing after 6. So then we know we're going to have a local minimum here. So then we basically know that this is going to give us the least amount of area when we make x equal to 6. Now, make sure you understand this concept, because I like to go, add a little more to this just to make sure that my students get this, because sometimes students get lost in the math and they forget what's happening. Because another way you can do this to double check this is take the second derivative. You take the second derivative and evaluate the second derivative of 6. If the second derivative is positive, if I basically take the second derivative at 6, it's just going to be positive because it means the graph is concave up, and then that's going to be local minimum. So you can do it that way or this way. Do it in a way that makes sense. Just make sure you're doing something to connect the problem, and of course make sure you finish it, because sometimes the problems what's going to be different dimensions into x, y, widths, and with margins in this case. So the minimum value of the area will happen when x is 6. And my area equation is right here. So I can find the area equation will be 2 times 6 plus 72, 6 to the negative 1, or 72 over 6 plus 30. So this will give me 12 plus 12 plus 10, 12 plus 12, 24, 52, 54. So my minimum area with 54 square inches. Whoa. 54 square inches when x equals 6. So when x equals 6, and when basically if x equals 6, remember we have an equation for y where it's 24 over 6, where y equals 4. So this would be 6, that would be 4, so that makes 6 times 4, 24. But the overall width of the paper width, we're talking about this whole thing. This whole paper width would be 4 plus 2, so that would be 6. And the length would be 6 plus 1.5 plus 1.5, 6 plus 3. Paper width would just be 6 inches. And the length would be 9 inches. Just make sure you finish the problem, especially on a test if that's what it's asking for, because you don't want to lose points just for that. And there you go.